This is a unique opportunity, and it's a great opportunity for us. For too long, and I'm guilty of this myself, there's been a huge disconnect between fire prevention people, fire suppression systems professionals, and us big macho firefighters, okay? Because we didn't want to spend any time in the Fire Prevention Bureau, and systems and codes and regulations are so dry compared to running calls. Well, we're professional firefighters, and as professional firefighters, a large segment of what we need to know has to do with fire suppression systems. This is an effort to close that gap, that disconnect between their industry and our industry. This is Adam Kroll. He's superintendent of Sprinkler-Matic, and he's going to be leading us through our activities this afternoon.
Hey, thank you for being here. My name's Adam Kroll, like you said, superintendent Sprinkler-Matic. We are a fire protection company, contractor per se, and we install automatic fire sprinkler systems in new construction and existing construction. This should be a good time. We're going to talk about components of the fire sprinkler system. We're going to talk about specifically fire pumps, standpipe, floor control assemblies, PRVs, which is a big one. You guys hook up to that, and also how we both work at the same time, and how I work by myself, or how our system works by itself, or how we work in conjunction with your pumper truck and your guys going into the stairwell. I'd like to get started with our system, okay? And our system starts with the city water main, okay? We have a dedicated water service that goes into any building, and that starts, depending on what municipality, from the city water main through the fire backflow. All right, here you can see next to me, this would be considered the fire backflow. This is a DDC VA double detector check valve assembly. It is, there's two double check valves in it, the big one where the water flows, and then there's a metered side.
Through the backflow, we either go directly into a riser system, or in this case, we go directly to our fire pump, okay? And what a fire pump does is a fire pump takes the pressure of the city water and it adds to it, okay? So what it adds is volume and pressure, okay? Everything on the backflow side would be city pressure. Everything on the discharge side of the fire pump is under pressure. Depending on the building and the circumstance, it gets pretty high, okay? To keep the pressure up in the building or to drain and fill, we don't use the fire pump, we use what's called a jockey pump. There's a small pump right here. When we drain, when we fill, when it loses pressure, this will keep the pressure in the building up, okay? The way the sprinkler system works is it all works on pressure. So a sprinkler head goes off or someone opens a valve, we start losing pressure on the discharge side of the pump. Pressure drops, jockey pump's going to start just to keep the pressure up, okay? If it's too much, like it's a real fire, sprinkler head goes off, jockey pump can't keep up with it, drops another 10 pounds, fire pump will kick on, and then you have the water to supply the fire in an automatic fire sprinkler system. So this is the jockey pump, this is the fire pump, this is a horizontal split casing fire pump, which means the casing is split horizontally to the shaft. This pump is driven by a diesel engine. You may see these electric, you may see them standing up, you may see the motor on the top, the pump on the bottom, you may see the one you have out front, vertical turbine. There's probably more steam turbine, you know, there's probably a bunch of different fire pumps you would see. Now, everyone firefighters here, or do we have civilians? All firefighters, okay. So you pull up to the building, do you guys send someone into the fire pump room?
You should, yes.
You should. So you come in, you hook up, you start getting water, you know.
One of the purposes of this class is we send somebody into the fire pump room. And it's like, okay, you were assigned the fire pump room. Now what? And part of the purpose of this class is that Greg, our pump guy, is going to explain what you would be looking for when you go in a fire pump. Is the pump running? And even more important than that, is it going to continue to run?
Right, and if the pump is running, that would mean loss of pressure in the system, okay? That would mean a head's going off, or someone hit a head, or there's an actual fire. So when you get in there, there's some things you should be looking for. Sort of like your pumper truck, when water flows, there has to be some kind of relief in the casing, okay? What's going to happen is, if the pump is running and it's not expelling enough water, or any water per se, let's say the fire pump's turning on and it's just turning a churn, you'll see a lot of water dumping out through what's called a casing relief, which is a pipe on the discharge side of the pump, and you'll notice that it keeps the casing cool. If it doesn't keep the casing cool, then you'll get a situation where it heats up, burns up, and just melts down the pump. All right. So you go into the pump room, make sure everything's working properly. Pump's running. It's not smoking. It's not heating up. You know, we're the primary water source on an automatic sprinkler system, or an automatic standpipe, a wet automatic. You come in, you're the secondary supply if there is a fire pump, which is what we're going to get to in a minute here. Okay. Components of the sprinkler system. So through the fire pump, it goes into a standpipe or a distribution piping, somewhat to either take it up the building, take it to a different zone, take it to a different building in the same facility. Okay, so you'll have a distribution piping, then you'll have maybe riser piping or standpipe. For all intents and purposes, let's say it's a high rise. So the distribution piping goes out to these standpipes that run up the building, that feed each individual floor. On the standpipes, there's going to be hose valves and hose connections for the fire department, so they can fight a fire on each floor. Also, in that distribution piping I was talking about, between the fire pump and the standpipes, that's where the FDC line comes in, or the fire department connection line comes in. Comes in after the fire pump, okay, unobstructed to the distribution piping. It would almost be like the equivalent of my discharge piping is the FDC inlet. Same spot, unobstructed, no valve, no shut off, going right to our distribution system to go up the risers. All right. When we get up the risers, then each floor has a shut off valve to the actual sprinkler system. Okay. Through that shut off valve manifold, we'll be looking at a little bit later. I have over there, we have the actual piping that has the sprinkler heads attached to it. So we have all this piping in, out of the pump, distribution, up the building, in the garage. Now we get to the floor control valve that shuts off the actual sprinklers that are going to go off during the fire. All right, so there we have in that sprinkler system, we have different components. We'll have steel pipe, hangers, sprinkler heads, we have CPVC pipe, just a plethora of different ways to put these automatic sprinkler systems in buildings, hide them or expose them, protect them when they're not behind drywall, or outside galvanizing, and different stuff like that. Any questions?